Greetings, third and second periods. Here we are in class. You're looking at a live image recorded on Wednesday morning of the people that are in the classroom. You can see they're wearing their masks and doing all that. So we're going to make a live video. Now come back around to my face. So it looks weird in here because I'm seeing computer light on my face. This is a live image from class. And I'm supposed to have my mask on, so I'm going to put that back on while I talk. Here. I'm going to make my picture go away. I hope you guys at home are doing well. We think about you. Okay, today's topics is functions. Let me zoom in so those in the class and on home can see the top of the page well. What I like to do is write my name on this in case I leave one in the classroom. Mr. Mitchell will put it in my folder, and then you can add the date to the top as well. So when we have our next test, you can kind of get your stuff organized. All right. There's some terms here. A relation. A relation can be graphed as a point or a set of points. So I can write a relation that's something like x and y. I can graph x on an x. I can go to an x distance on an x-axis and up y like we did in Battleship. And I can have a point, and that is a relationship between two variables. So if I illustrated it, and I had the point 2, 1, I would count over 2 and up 1. And there is a relation. There are two variables that decide where this point is in space. But a function, specifically a function, is a special type of relation. To be a function, each element of a relation's domain, the x values, must pair with exactly one element of its range, the y values. And we're most familiar with this recently from playing the game of Battleship on a coordinate plane that had x's and y's. And when you guys guessed a location where their ship was, well, you either put a 0 or an x there after you found out whether they'd hidden their ship at that location. Okay, so this definition, this long one, to be a function, each element of a relation's domain must pair with exactly one element of its range. This gets broken down a little further into these statements. Now we're looking at multiple points. A set of data is a function if each x is paired with exactly one y. And the way that teachers will say this is that the x's don't repeat. Let's look at a couple of examples. Here's a set of data. There are 4 points in this set. 1, 1, 2, 4, 3, 9, and 4, 16. To be a function, I'm going to ask a yes or no question. Do the x's repeat? There's a problem with a function if the x values repeat that we're going to see in a minute. So I look through this set of data, 1, 1, 2, 4, 3, 9, and 4, 16. I see no repeating x values. So that passes this first test for whether it is a function. Yes, this one is a function. One value of x would go into an equation, and only one value of y would come out for each of those x's. So let me write this over here for our second one. A little different form of presenting data here. They give me an x Say again, Tony? Yeah, this one says Tony on the other side of the room is a no. Why? And if you can't hear it at home, -4 repeats.
Also
-4 repeats as an x value. So this kind of breaks the rules of a function. If I put -4 into an equation and out comes this g of x, this is the y term of the function, and out comes a 7, okay? -4 goes in, out comes a 7. But the next time I do it, in goes -4, and out comes a 10. That breaks the rules of math. Math equations should give me one answer. If a number goes in for x, I should get one number to come out for y. I can't put -4 in the second time and get a different answer. You can't write an equation that makes sense for that. The -3s also repeat. So this one is no. It is not a function. There is a relationship between these points. It is a relation, but it is not a function. It is a no. Okay. Folks in the room, questions for me? Thank you. Let's look at this piece down below. This is the second qualification to be a function. A set of data is a function if a vertical line will cross the graph at only one point anywhere on the graph. Only one point. Okay. So this is my x-axis, this is my y-axis, and these points have been laid onto the graph. These are also yes/no questions. And Tony, what do you say?
if you draw a line down each one,
Right.
it's 2.
So if you draw a line, vertical line test they call it, that point is good. Only one x gives you one y, but the second one fails right here.
Therefore, it's not.
This is not a function. These 2 points, I have 1, 2, 3. I have x is equal to -3, 1, 2, 3. And x is also equal to -3, and out comes -1. This breaks the rules of math. If I put in an x, I should have only one value of y come out. So this is a no because it fails the vertical line test. That was the bell for a lunch, and my stomach's starting to growl. Okay, let's look at this second one. Instead of points, they now have a line shown. The line has a curve in it. This is my x-axis, and this is my y. Yes, no is the question. What do you guys think? I think it's also a yes. Anywhere I draw a vertical line, I only hit this function in one spot. Even up to the very end, there's just one place where it touches at 5, 0. So this one, yes, is a function. Okay? This graph, yes, no. It is also no. Good job, Jonas. If I draw a vertical line pretty much anywhere in this graph, 1, 2 locations where this function on a graph has multiple x's, the x's repeat. It fails the vertical line test. because I've got over 1 and up 2.5, 1, comma 2.5. And it looks like I also have over 1 down 3.7. Over 1 up 2.5, over 1 down 3.7. The x's repeat. I have the same value for x with different values of y. It is not a function, and it also fails the vertical line test.
I'm getting off.
There's no chill. Just comply. Okay.
Did you just say the bill for lunch just went off?
Yeah, the other lunch.
Oh, dang.
Okay. I'll leave this up here for a minute. Folks at home, this should give you enough to go on to answer 10 questions in a Google form you'll find now posted into the classroom. We're going to finish this video recording here, post that to Google Classroom, and then you'll have a chance to answer 10 questions on whether a set of data are make a function or not, and use these notes as your base.
Can I have that paper up there?
Good luck, y'all.
It's hard to see up there. We should freeze it.
I will.